Aryabhata, who lived from 476 to 550 CE, stands out as one of the most influential mathematicians and astronomers of ancient India. His groundbreaking ideas, really transformed the understanding of mathematics and astronomy, not only in India but also in other parts of the world through later translations and influence. Aryabhata is best remembered for his major works, the Aryabhatiya and the Arya Siddhanta, and for introducing concepts that, remain fundamental to modern science and mathematics. Aryabhata was born in India, most likely in Kusumapura, which is modern-day Patna in Bihar. Some sources suggest he may have originated from Kerala, but his association with Kusumapura is widely accepted. This city was honestly a major center of learning during his time. Aryabhata is believed to have studied and possibly taught at the renowned Nalanda University. He also established an observatory at the Sun Temple in Tarragana, Bihar, which allowed him to make precise astronomical observations. Aryabhata's contributions are preserved mainly in two important texts. Aryabhatiya, completed in 499 CE when Aryabhata was just 23, is his most famous work. Written in Sanskrit verse, it is structured for easy memorization and divided into 4 chapters. Kitikapada discusses cosmology and the concept of vast time cycles called Mahayugas, which are millions of years. Ganitapada focuses on mathematics, including arithmetic, algebra, geometry, and methods for solving equations. Kalakriyapada deals with the calculation of time and planetary periods. Golapada explains spherical astronomy and trigonometry. Arya Siddhanta, although this work survives only in references by later scholars, focused on astronomical calculations and described various instruments for observation, such as the gnomon, also called Shanku Yantra shadow instruments, angle measuring devices, and water clocks. At a time when, most people believed the sky revolved around a stationary Earth, Aryabhata proposed that the Earth actually rotates on its axis from west to east. He explained that this rotation is what causes the apparent movement of stars and, of course, the cycle of day and night. Aryabhata used a really simple analogy. Just as a person in a moving boat sees stationary objects appear to move backward, people on Earth see stars move across the sky because of the Earth's rotation. This idea was honestly centuries ahead of its time, predating similar European theories by Copernicus and Galileo. Aryabhata was the first in India to provide a scientific explanation for solar and lunar eclipses, moving away from, mythological interpretations. He explained that a lunar eclipse occurs when the moon passes into the Earth's shadow. A solar eclipse happens when the moon's shadow falls on the Earth. He calculated the size and duration of eclipses using geometry. For example, in 1765, French astronomer Guillaume Le Gentil found Aryabhata's prediction for the duration of a lunar eclipse was off by only 41 seconds, despite being made over 1,000 years earlier. Aryabhata calculated the length of the sidereal year, that's the time taken by the Earth to orbit the Sun relative to the fixed stars, as 365 days, 6 hours, 12 minutes, and 30 seconds. The modern value is about 365 days, 6 hours, 9 minutes, and 10 seconds, making his calculation only about 3 minutes longer than the actual value. That's honestly a remarkable achievement for his era. Aryabhata stated that the Earth is round and calculated its circumference as 39,968 kilometers. The actual value is about 40,072 kilometers, so his estimate was extremely close, with an error of less than 0.3%. Aryabhata described a geocentric model, with Earth at the center, but he also made important observations about planetary motions. He explained that the moon and planets shine by reflecting sunlight, not by their own light, which was a significant step forward in understanding the solar system. Aryabhata was one of the earliest mathematicians to use the decimal system and introduced 0 as a placeholder, which made calculations much easier and really laid the foundation for modern mathematics. Although he did not use a symbol for 0, his place value system implicitly included it, allowing for more complex calculations and the development of algorithms for square and cubic roots. Aryabhata calculated the value of pi as 62,832 divided by 20,000, which equals 3.1416, very close to the modern value of 3.14159. He also understood that pi is an irrational number, meaning it cannot be exactly expressed as a fraction. Aryabhata gave the correct formula for the area of a triangle, stating that the area is equal to half into base into height. He also accurately calculated the area of a circle. Aryabhata developed methods for solving quadratic equations and introduced the Kutaka or pulverizer method for solving linear indeterminate equations, which are equations with more than one possible solution. This method is actually similar to the Euclidean algorithm used today to find the greatest common divisor of two numbers. Using the Pythagorean theorem, Aryabhata constructed a table of sines, an important concept in trigonometry that is still used in mathematics and engineering today. Aryabhata's work had a profound impact on later mathematicians and astronomers in India and beyond. His ideas influenced scholars such as Brahmagupta, who built upon Aryabhata's ideas and advanced the understanding of zero and negative numbers. Bhaskara I wrote detailed commentaries on Aryabhata's works, helping to spread his ideas. Varahamihira, another important Indian astronomer, was also influenced by Aryabhata's discoveries. Aryabhata's works were translated into Arabic and later reached Europe, where they influenced Islamic and European scientists during the Middle Ages. His approach encouraged the use of observation and logic, moving away from superstition and myth. Today, Aryabhata's name is honored through institutions, satellites, and awards in India, and his legacy continues to inspire scientists and mathematicians worldwide. Aryabhata was a true pioneer whose discoveries laid the foundation for modern mathematics and astronomy. His use of the decimal system and zero, accurate calculation of pi, and scientific explanations for astronomical phenomena like eclipses and planetary motion were far ahead of his time. Aryabhata's work helped shift the world from superstition to science, and his ideas remain relevant and respected even today.